Welcome to Spring LIB.
So according to this problem, a vertical spring is attached to a table. So we have, this is the level of the table here, and attach a vertical spring to the table. And there is a ball which is kept just in contact with that. It's not actually attached to the spring. So what is happening is that the spring is compressed and the ball comes in this location. And when it is compressed, what actually happens is that the spring comes to the unstressed length, at this location, and the ball goes up in the air afterwards here. So I'll label it as 1, 2, and 3. So it says that what upward speed can be given to a 0.380 kilogram ball. So the mass is 0.38 kilogram. And what upward speed can be given, which means that we need to find out the value of V2 at this location. So this is the problem here when released. So to solve this problem, what we're going to do is that in our system, in this whole system, we have the conservative forces acting. So the energy is conserved. So we're going to equate the energies at E1, at level 1 and level 2. At level 1, the total energy of the object is half m v1 squared plus mgy1 plus half k x1 squared. And at level 2, the total energy is equals to half m v2 squared plus mg y2 plus half k x2 squared. So we're just considering all three energies at both the locations, and then we'll see which energy is present at which location. So let's first of all see at level 1 which energies are present at this location here. So at this location, as you can see clearly that the object is at rest. So in this equation here, we have this one 0, and since the object is pressed down from this level here, for our simplicity, we are going to take our 0 GPE at this level, which means at this level x is equals to 0 and y is equal to 0. Now you can solve by taking this reference point at any level, but I prefer this way. So therefore, at this location 1, we have the kinetic energy is 0, but there is a potential energy at this location. So therefore, I'll write mgy1, note it's negative, plus half kx1 squared. Now for this location here, for level 2, the ball is just in the middle and it is just about to be released from the spring. So at this location, we'll have the kinetic energy half mv2 squared, and we'll have the potential energy also at this location, as you can see, which is 0, because this is a assumed 0 reference level. And since the spring is not stressed at this level, the elastic potential energy is also 0. So if you solve this equation and rearrange, we are going to get an equation V2 is equals to k x1 squared plus 2 mgy1 divided by m. You just plug in the values in this equation, and you'll be getting the answer of 7.47 meters per second. So which means the velocity is at this point is 7.47 meters per second. And then it says for the part B that how high above its original position spring is compressed when the ball will fly. So now in this case, we'll equate the energies at E1 and E3. So at E1, the total energy is half mv1 squared plus mgy1 plus half k x1 squared. And at the third location, at the number 3 location, we'll have the energy is half mv3 squared plus mgy3 plus half k x3 squared. So at location 1, we have already seen at this location, the kinetic energy is 0, and we have the potential energy is mgy1. Note it's negative when you're plugging in afterwards, and the elastic potential energy is half kx1 squared. At the location 3, however, the ball is at rest at the highest point, so there is no kinetic. The ball will only have the GPE, which is mgy3, and the spring is just unstretched. At that location, there is no elastic potential energy in the system, which is 0. So if you solve that, you will get y2 minus y1 is equals to kx1 squared divided by 2mg. And if you plug in the equation and the values of x1, which is 0.16 meters, and this is 875, and this is 2 times mass and gravity, you will get 3.01 meters. And that is our answer for the B part.